In this video, I want to introduce you to one of the simplest, most straightforward, and yet most useful tests that you'll ever encounter, and that is the sign test. We are going to look at 4 different use cases for the sign test, beginning with using the test for non-numerical comparisons among 2 matched participants. First, a bit of history. The sign test is the first recorded hypothesis test originating in 1710 by John Arbuthnot. Even though the general discipline of nonparametric statistics was fully developed after parametric statistics, this particular test is a nonparametric test that preceded all parametric statistical inferential methods. In this first use case for the sign test, we're going to set up a situation in which we have 2 matched participants. What does it mean to be matched? It means that we have access to an extraneous variable, and we can find participants that are similar to one another on that extraneous variable. In order to be an extraneous variable of any use, this variable needs to be related to the outcome measure that we're going to be using in our study. For example, suppose we are going to be looking at reading achievement. We could match participants on their prior reading achievement levels, or match participants that are at the same reading level. Suppose we're going to look at a treatment for a disease. We can match on the progression of the disease that's currently exhibited by the patients. If we are going to look at any sort of test score, perhaps we have a pre-test score, in which case we can match participants who had the same or similar pre-test scores. If we're looking at an outcome measure related to age, then we could use age as the matching variable. If we are going to look at the effects of a drug that might influence heart rate, or perhaps the effects of exercise on heart rate, we can start with participants that have similar heart rates. The basic idea is to match 2 participants so that they are as similar as they can possibly be with respect to the outcome response measure that we're going to study. Now we use some random methods such as flipping a coin in order to assign these 2 participants to treatment and control conditions. Once we have done that, we will have the same number of participants in the treatment condition as we do in the control condition, and we know which participants in the treatment are matched with those in the control. When we use good extraneous matching variables, we have created a treatment condition that is very similar to the control condition with respect to those variables that influence the outcome. All variables, that is, except the treatment that is actually under study. Now here comes one of the most useful aspects of this inferential procedure. When we compare individuals in the treatment and control, all we are doing is looking to see where there was the most successful outcome, whether it was for the treatment participant or for the control participant. For each pair, we can symbolize whether the treatment member of the pair was more successful by using a plus sign, or whether the control participant of the pair was more successful by using a minus sign. This test has a broad range of applications because it really does not matter what technique we use to determine success for the treatment or control participant. More on that in a moment. The test statistic that we use is the number of plus signs. In this particular example, we have 7 matched pairs and we have 6 plus signs. The test itself is just a simple case of the binomial test. If you have not studied the binomial test, I recommend you go and watch the videos in that series. In this particular instance of the binomial test, we are looking at the proportion of the number of plus signs in the total number of pairs, with our null hypothesis being that these will be 50% of the signs. Why are we using a proportion of 0.5 for the null hypothesis? If the treatment is not effective, then whether the treatment participant or the control participant exhibited the most successful outcome is just a matter of chance. When there is no difference in the effect of the conditions, the plus and minus signs are equally likely. Because this is a binomial test, we can use the same sort of table that we use for a binomial test. Here I'm showing for our 7 matched pairs all the possible outcomes for the number of plus signs, where, remember, the plus sign indicates that the treatment member of the pair was more successful. We could have anywhere from 0 to 7 successes in 7 matched pairs. In our particular case, we obtained 6 matched pairs, We are using an upper-sided alternative hypothesis because we're interested in a positive effect of the treatment. The probability of obtaining 6 successes, if in fact the treatment is not effective, is 0.0547, or more important for this test, the probability of 6 or 7 successes is 0.062. In other words, our p-value is 0.062. Therefore, in this particular instance, if we have selected an alpha of 0.05, we will not reject the null hypothesis. If we had selected an alpha of 0.10, we would reject the null hypothesis. Remember, however, that the selection of alpha comes prior to conducting the test. There are alternative tests that we could be using instead of the sign test. For instance, we could use the t-test for matched pairs, that is the one sample t-test. So why the sign test? The only condition for valid inference is the independence of pairs. Obviously, the inferences that we make back to the population depend upon random selection from that population, and the accessible population is certainly not the same as the target population, but if we randomly select from the accessible population, then we can make inferences about the parameter of that accessible population. Aside from that, the only condition we need is the independence of pairs. We do not have independence within a pair. We have purposefully matched, so we have a correlation within a pair, but we do need to ascertain that the pairs are independent of one another. Here is what makes this test so general. Comparisons within pairs can be based on any outcome variable or combination of variables. Think about the possibility. If you are looking at a medical treatment, a physician's assessment of which patient improved the most is sufficient for determining whether that pair gets a plus sign or a minus sign. That is, whether the person who was assigned to the treatment condition had a more successful outcome than the person in the control condition, or vice versa. We don't even need a numerical assessment. The physician could make a holistic determination of which patient improved the most, perhaps relying on a number of different variables. In another example, a teacher could assess which student is more engaged in study. Again, the teacher can use multiple indicators. No numerical values are needed. Or perhaps we have numerical values, but they don't rise to the level of a quantitative variable such as would be needed for the t-test. Perhaps a rating on a Likert scale is what you're using to determine whether you have a higher value for the person in the treatment condition or the person in the control condition. So this is a very general test that does not need to rely on, although it could, numerical comparison. Inference options include both a hypothesis test and a confidence interval. Now, specifically for the sign test, it is a test, and rejection of a null hypothesis provides confidence that the treatment works. But if we want to recognize the sign test as a special case of the binomial test, then we can build a confidence interval, just like we did for the binomial test, that provides confidence for the percentage of the population that will be helped by the treatment. That is, a lower bounded interval if we are looking to see if the treatment produces more success than the control. In a case in which the study participant can actually be a part of both conditions, then that's the best kind of match that you can have. That is, this version of the sign test can be used in a pre-test, post-test design, where you measure a participant prior to a treatment or an intervention, and then measure them again after the treatment or intervention. Assuming that an increase in scores is desirable, a post-test score that is higher than the pre-test score will yield a plus sign. A post-test score that is lower than the pre-test score will yield a negative sign. Another reason to use the sign test, aside from its broad applicability, is that it has some strong statistical properties, but we'll explore that in a later video.